All right, so today is Thursday the 19th. You should have you've had time to complete your warm-up, after which the notes that we're going to take for our note card project, we're going to do exponents today. Okay. We ended up doing types of slope yesterday. We're doing exponents today. We're going to finish scientific notation. We're doing word problems. And then we have some problems that we're going to do in our blue book. Thank you, baby. We did that, yeah, we did. Is there anyone that didn't finish the survey that's on my homepage? Okay. The survey we did in class together.
Oh, I did.
Yeah, I think it was like 2 surveys.
Yeah.
All right, so tonight I need you to study your note cards.
Which ranch one was this?
That one survey.
You wasn't here. You have to do it. You was absent last week.
Can I do it on my phone?
Yeah. Can you put that down? Everybody knows you're on your phone. It's just we all know. It's not a secret.
I was on my phone. I was really looking at my
Okay.
notes.
Well, make sure you go ahead and do that and then put it away. Okay. No homework help video for Thursday. Is that a different concept? I may do one. If I have time, I'll do a homework help video. Okay. Because I think it's a different topic. What you need, baby?
The code.
Or that's your student ID. Yeah. Sure, the code for a student ID. If you haven't done that, please make sure that you go in and get that taken care of. Planner, please pull that out. Check off the stuff that you have already done. If you did these things, check it off. If not, don't check it off. Okay, now we're doing Thursday, Math 8. We got homework, Math 8. We need to study note cards. And guys, your interactive notebook. If you don't have notes from interactive notebooks, then you need to be asking me for those notes. You can text me, I can send you pictures, or you can go back and watch the videos. Okay, tomorrow we're submitting work and we have our quiz on scientific notation and laws of exponents. Please study, study, study. I'm gonna pause for the calls. Bathroom folks, let's go. The rest of us need to be working on our homework. All right, let's look at the warm-up. A square has an area of, and this is 49 over 81 inches, okay? What is the length of each side? All right, so the formula for area of a square, bless you, is S to the second power. You plug in the area, which is 49 over 81, okay, and you solve for S, the side. You're looking for the length of each side. So that'll tell you. What's the opposite of squaring? Please pay attention. What's the opposite of squaring a number?
Square root.
So you have to find a square root on both sides. So this means I find the square root of both the top and the bottom. Okay? I'm gonna write this, top and bottom. What's the square root of 49? 7. What's the square root of 81?
9.
This is our answer. Okay? Charles is in a hot air balloon that has risen up from the launch point. Okay, so it's going up. Let's see. Matthew is standing on the ground at 7 meters from the launching point. So from here to here is 7 feet. Okay. All right. Let's see. If Charles and Matthew are 25 feet apart, 25 meters apart, how far is the balloon?
Oh, you meant 7 meters, you 7 feet.
Meters, that's right. Alright. What don't make sense? Hold on. Oh, he's standing 7 from the launching point. This is 7.
Oh.
This is nothing.
I gotta figure out how far apart with the slanted
Yeah, we gotta figure out.
diagonal.
This is 25. So we're trying to figure out this. Okay. Alright, Jesus. Fix it. Alright, so this is what that is. The part that I read wrong was the first part. It didn't give us this measurement, it just gave us this measurement. Okay, so I put 7 here, because there's a period right here, it stopped. It didn't give us this, but it did give us this and this. Okay, blessed Father. Alright, so here, obviously, this is Pythagorean Theorem. And this is the slanted side. And this is, well, that, A could be missing, and then B could be given. So we got A squared plus 7 squared. What's 7 squared?
14.
No, not 14, that's
Oh,
7 plus 7.
yeah.
49. And what's 25 times 25? Somebody said it.
625.
625. So now what do we do to figure out what this A is, what this is in meters? Because these are obviously meters. We have to,
49.
very good. And that gives us A squared is equal to, type this in if you don't know it, 625 minus the 49. What does that give you? Come on, y'all. Type. Or subtract. 576. So now we're gonna find the square root on both sides. What's the square root? Type it in. Second x squared. What's the square root of 576? How many? 20.
Mr. Reyes, can I text my mom real quick?
You have to step outside.
Alright.
All right. Any questions, comments, or concerns? Tomorrow I want to do this one, so please don't scratch this out. We'll do this tomorrow before we submit. Okay? All right. Pause for the cause. So you definitely need this sheet, the word problem, but we're gonna do no part first. Okay? All right. So with our note cards, the first note card was what? The area formulas. These are area formulas. Okay, area of a square, S to the second power. Rectangle, length times width. Circle, pi r squared. Parallelogram, base times height. Triangle, 1/2 base times height. Trapezoid, 1/2 height, B1 plus B2. Those are your area formulas. Please make sure that you know these by heart. They're not going to give those to you, okay, if it comes up in questions. Volume, okay, the ones that you're going to probably see the most is the cylinder, the cone, and the sphere. Remember those especially, okay? You have a cube, S to the third power, rectangular, length times width times height. Length times width times height. This is a rectangular prism. Should put prism, I'm sorry. Cylinder, pi r squared times height. Pi r squared times height. Cone, 1/3 pi r squared times height. 1/3 pi r squared times height. 1/3 pi r squared times height. Look at the two. The only difference is the cone is smaller. It's 3 times as small. The cylinder is 3 times larger. That's why this is a third of a cylinder. The sphere, 4 over 3 pi r to the third power. 4 over 3 pi r to the third power. Okay? This one's a little weird. All right? The third card. What's the third card? Hello? What's the third card? No, that's 4. Pythagorean Theorem. Okay, make sure you have them in order, please. Pythagorean Theorem. That's a squared plus b squared equals c squared. These are your legs. This is your A and your B. Your legs form the right angle. The side opposite of the right angle is the hypotenuse, C. It may not always look just this clean cut. It may look like, look, this could be the slanted side, and this could be the right angle. Do you see that? It looks like this could be, but look at these angles. This is not a right angle here, and this is not a right angle here. The side opposite of the right angle is C. So this will be my C, and this will be my A or B. So keep that in mind, okay? Yes. Area formulas is 1. Number 4 is slope and rate of change. There are 2 formulas for slope and rate of change. The first formula is rise over run. When do you use rise over run? When you're given a line. Or if they give you a ramp and ask you for rise over run. Please don't always assume you use Pythagorean Theorem. Read the question. If they say find the slope, give them the slope. If it's a picture, use rise over run. If they give you 2 points in the picture, use the slope formula for 2 points. y2 minus y1 over x2 minus x1. If they give you a long table, they're either going to tell you what 2 points to use, or it doesn't matter. You can use any 2 points. Okay? Read the question. The 5th note card, slope-intercept form. This is for linear equations. The slope-intercept form is y equals mx plus b. Y equals mx plus b. Where the number attached to the x is the slope, and the number that has no variable attached to it is your starting amount, or your y-intercept, or it's where the line crosses the y-axis, your y-intercept. That's the definition of y-intercept. All right? The 6th card. The 6th card is the kinds or types of slope. There are 4 different kinds or types of slope. You have positive slope. That's where the line from left to right, the line is going up. That means m is a positive number. You have a negative slope. That means from left to right, the line is going down. That means m is a negative number. You have where your slope is a flat line. Look, horizontal lines, those are flat lines, have no steepness to it. So it's a flat line like these floors. They have no steepness. M is 0 for flat lines. Undefined slope is a line that goes up and down like the walls. Okay, you can climb it, but you couldn't walk the wall. These have undefined slope. Okay, that's where you have a number on top and 0 on the bottom. A number divided by 0 is impossible. So when you get this as a final answer, you know it has an undefined slope. Questions, comments, or concerns? Please study. This is the 7th note card. This is exponents. We're doing laws of exponents. Okay. All right, so we have multiplying exponents, and this is card 7, with like basis. You can only do this if the bases are alike. Like basis. Yes, baby?
Do you have an extra word worksheet for the word palette?
Yes. Mm-hmm.
What's that last word?
Basis. This is an easy project, right? Okay, it's gonna be super easy. Just keep up with the notes. All right, here we go. So if you have 3 to the 5th power times, I'm gonna use the dot for multiplication, 3 to the 2nd power, this is saying that 3 is being multiplied 5 times. 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. That's this. Okay? Then we got times. 3 is also being multiplied how many times? 3 times 3. So how many total times is 3 being multiplied? 1, 2, 3, 4, thank you, 5, 6, and 7. What's the shortcut way to do this? What's the shortcut way that I could have answered this problem? What could I have done with the exponents? Add the exponents. That's the kicker. Add the exponents. 3, we got 5 plus 2, so this is 3 to the 7. Add the exponents. Let me make this look like something better. That looks stuffy. Sorry. Try this. 2 to the 6th power times 2 to the 8th, 2 to the 8th power. Try those. All right, let's see what we have. What do you do here to get the answer? What are you going to do with the exponents? Add them. So that's going to be 6 plus what? No, 8. Come on, y'all. Please, come on. Count, even if you have to use your fingers and your toes. 6, 7, 8, 9, 10, 11, 12, 13, 14. Raise your hand if you got that right. Okay. Thank God. What do we do with the exponents here? Add them. So what are we adding? 4 plus 3. What's 4 plus 3? 7. Very good. Raise your hand if you got that right. And more people. Good. All right. What do we do with the exponents here? Add them. What are we adding? If you don't see an exponent, what is it automatically? It's automatically 1. So you add, very good, Jay. 1 plus 5. And what does that give you? 6. Raise your hand if you got that right. Okay, very good. The last one. What are we going to do with the exponents? Add them. So what are you adding? 0 plus 9. And what does that give you? 9. Raise your hand if you got that right. Perfect. Raise your hand if you are still writing so I can wait. Okay. All right, here we go. The next card. This is 8. This is dividing. Exponents. With like bases, okay? The bases have to be alike in order for you to do this, okay? All right, let's do it.
Yeah, I literally woke up hugging that.
Let's do, what number? I have 5. Let's do 5. 5 to the 7th power divided by 5. Let's do 5 to the 2nd. No, I did 2nd already. Let's do 3rd. Okay? All right, so this on the top is saying 5 times 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6. One more. 7. 1, 2, 3, 4, 5, 6, 7. Just making sure, okay? On the bottom, this is saying 5 to the third, so that's multiplying 5 times itself 3 times. Okay? 1, 2, 3. Got it?
Yeah.
5 divided by 5 is 1. 5 goes into 5 one time. 5 goes into 5 one time. 5 goes into 5 one time. So how many 5s do I have left?
4.
I have 4 5s. So this is 5 to the 4th power. On the bottom, it's 1, but you don't need that, do you? You just need 5 to the what? 4. Okay? Any questions? What's the short way to do this?
7 minus 3.
Just subtract. 7 is the top exponent minus 3 is the bottom exponent, and it's still going to give you the same answer of 4. Questions about that? Shorter one. Let's do this one. Different number. I haven't used 6, okay? Let's do 6 to the 2nd power divided by 6 to the 5th, okay? So on the top, this is saying what?
6 times 6.
6 times 6. On the bottom,
6 times 6 times 6.
how many times is 6? 1, 2, 3, 4, 5. Good. Yes, baby.
Alright. Option.
Not right now. Okay.
Shut up.
All right, so here we got 6 goes into 6 one time. 6 goes into 6 one time. Okay. So on the bottom, this time you have what?
3.
You have 1 on the top. 1 times 1 is 1. And on the bottom, how many 6s?
3.
3 6s. Okay. Got it? So now look. How do I do this? The short way to do this is to say 6 to the what?
3rd.
6.
Second power? Yeah.
2 minus 5. What's 2 minus 5?
3.
Negative 3. How do you write a negative exponent? 1 over 6 to the positive 3. Bring it down to the bottom to make it a positive exponent. Don't forget to do that. Questions? Try these, okay? See what we have, okay? All right, so this, what are you going to do with the exponents? And I forgot to write that big and pretty, y'all. What do you do with the exponents?
Subtract.
You subtract exponents. Please write that somewhere on the card, okay? That's super important. So let's subtract. We're going to say what minus what?
7 minus 6.
We're going to say 7 minus 6. What's 7 minus 6?
1.
1. So that's 4 to the 1 power or just 4.
Are we doing the scientific notation in one of these calcs after this?
Yeah, not today though, but we are. All right, let's do this one.
8 minus 1.
8 minus 1. What's 8 minus 1?
7.
Don't forget, if you don't see an exponent, it's automatically 1. Let's do this one. What do we subtract here? What minus what?
3 minus 4.
3 minus 4. What's 3 minus 4?
Negative 1.
Negative 1. How do you write this?
1 over 8.
1 over 8. And you can say 8, 1 over 8, or 8, 1 over 8 to the first power. Same thing. Any questions? You okay? Last card that we're going to do today is power of the power. Exponent raised to another exponent. Anybody still copying? I'm sorry. Kylie, you got it, baby? Next card, this is card number 9. Power of the power.
No, it's not a 10. Number 9 was divided.
That was 8. 8
Oh.
somebody. That's okay, baby. Power of a power, or it's exponent raised to another exponent. I'll pause to give you a chance to write, okay? All right, let's do it. We have, let's suppose that we have, what number haven't I used? 1, 2, 3, 4. Let's do 4 to the second power. Let's raise that to the third, okay? So here, you're going to, when you have an exponent raised to another exponent, you multiply the exponent. Okay? So this is going to be 4 is the base.
To the 6th power?
Very good, baby. 2 times 3, which is 4
I think everyone just dead eyed me for a minute.
power. No, it's okay. We're over. All right, so multiply the exponents. Got it? Try these. This one's easy. All you're doing is multiplying. Power of power, multiply. Power of power, multiply. So let's try these, okay? All right, let's see what we got. What did we do to the first one? We got 5 as the base. What did we do?
Multiply 5 and 6.
5 times 6. What's 5 times 6?
30.
So this is 5 to the 30th. Raise your hand if you got that right. Excellent. All right, what are we doing here?
4 times 2.
4 times 2. What's 4 times 2?
8.
So this is 8 to the what power?
8.
Raise your hand if you got that right. Okay. What about this one? What do we do here?
7 times 3.
3 times 7 or 7 times 3. What does that give you?
1.
So this is 16 to the 21st power. Raise your hand if you got that right. All right, very good. Put this on your key ring, please, and put this in a safe place. Remember, this is a project grade. Any questions? I'm going to give you time to do that, and I need you to take out the scientific notation word problems. Clear your calculator. 2 plus 7, 1, 2. We'll pause for the pause. Okay, we're going to write these numbers in scientific notation. Oh, what I did with my count. Hold on. Okay, first things first. They're telling you the speed of light is 186,000 miles per second, and or about 771 million miles per hour. Okay. So this is second. This is hour. How would you express these numbers in scientific notation? Okay. Good people? Excuse me. All right, so first things first, let's look at this one. We locate the decimal. Where is the decimal in this number?
The last one.
Behind this last number. Where do we move that decimal to?
Behind the 6.
Not behind the 6. What's the first significant digit?
1.
The 1. The first digit you read from left to right. So we need to put it behind the 1. Let's count how many times you count to yourself and then write that number in scientific notation and see if we got the same answer. Do this on your own, please. Scientific notation. All right, so let's look at it. We're going to move it 1, 2, 3, 4, 5 times. So this is 1.86 times 10 to the what?
5th power.
5th power. Positive or negative?
Positive.
Positive. How do you know it's positive?
And the number is bigger than
Because the original number is bigger than 1.
1.
Raise your hand if you got that right. All right, I want you to try the second one, please. All right, let's see, what did we do? Okay, so first step, what are we doing?
Find the decimal
Locate that decimal. Where's the decimal if you don't see it?
at the end.
At the end. Where are we gonna move the decimal to?
Behind the
Behind the 6. The 6 is the first number that you come to. So count 1, 2, 3, 4, 5, 6, 7, 8. So we rewrite that new number 6.71 times 10 to the what power? Positive or negative?
positive
Why is it positive?
because the number is bigger than 1.
The original number is bigger than 1. Okay, let's read. How many people got that right? Okay. Let's read number 2. It says the speed of sound depends on the type of medium and temperature of the medium that it travels through. Okay, the medium is the device that's being used. Okay, the speed of light. The speed of sound in dry air is 15 degrees Celsius, which is also 59 degrees Fahrenheit. Is about 763 miles per hour. Rewrite the number in scientific notation. So we're rewriting this number in scientific notation. Do that now. 763, rewrite in scientific notation. All right, so what are we going to do to write this number in scientific notation? Find the decimal. Where is the decimal? Behind the 3, behind the last number. If you don't see it, it's behind the last number. Now what do? Move it where? Behind the 7. How many times do we move it? 2 times. So we rewrite this as what?
7.63 times 10 to the second power.
Very good. Raise your hand if you got that right. All right, good. Number 3, a human heartbeat heartbeats an average of 80 beats per minute. How many beats is this an hour? Express answer in scientific notation. Okay, so if it's 80 every minute, then how do you figure out how many beats it's going to be for an hour?
Count 80, 60 times 80.
80 times what?
60.
80 times 60. Very good, because it's 60 minutes in an hour. So you got 80 times 60. So let's multiply. We got 80 times 60. And then we're going to write in scientific notation. 2 zeros. And then what's 8 times 6?
28.
How do we write this number in scientific notation?
Put the decimal
Move the decimal how?
behind.
Behind the 4. How many times do we have to move it?
3.
1, 2, 3. So how do we write this in scientific notation?
4.8 times 10 to the third power.
Okay. All right, I'm gonna read this one, and then you try to figure out how much it's gonna be in a day, and put it in scientific notation. How many heartbeats is this in a day? Okay, so we already got the heartbeats for an hour, right? If that's 1 hour, then how much would it be for a whole day? I'm gonna pause for the cause. I'm pause for the cause. You figure it out. Don't forget that this right here, this amount, was for an hour. You want to figure out what it would be in a day and write it in scientific notation. All right, so what do we do to figure that out? What do we do with the hour amount?
You multiply by 24.
Multiply it times the 24, because it's 24 hours in a day. So look, sorry y'all, 4,800 times 24. What does that give us?
115,200.
Very good. 115,200. How do we write this in scientific notation?
Put the decimal
Locate the decimal and move it where?
behind the 5.
Behind that, no,
one.
behind the first one. How many times did you move it?
5.
1, 2, 3, 4, 5. Very good. So that's 1.152 times 10 to the what? Fifth power. let's look at the next one. How many heartbeats in a year? So we have for a day, this is the day.
How many days?
And how many times it's gonna be in a year? I need you to figure that out and write it in scientific notation. All right, here we go. So now, how do you figure out the year? What do you do? Times what?
That number by 365.
365.
What?
It's 365 days in a year.
Who
This is for every day.
How am I supposed to know that?
Who remembers
You
this?
gotta know that. It's 365 days in a year. You got listen, you do have to know that, okay? So make sure you understand, because they give you the day. So you have to figure out how much is in a year. So there are 365 days in a year. You do have to know that. We'll finish this up tomorrow before we take our quiz. Please, if you have time, please complete this so you'll already have the answers.
I'm smart today.
Shut up, I just figured out how to.
You are smart.
The first time.
Smart.
I'm better before Taylor.
Yeah.
Shut up, I just suddenly ate.